prove cos 3 theta is equal to 4 cos cube theta minus 3 cos theta, or the sine 3 theta one below it, we first write down the Myers theorem. So the Myers theorem, taken from page 20 of your log tables, and what we do is we let n equal to 3. So again, it's just a matter of knowing that one of these proofs requires using the Myers theorem, and knowing that we leave the power, or n, equal to 3. So from there, I'm just going to let n equal to 3. So r by cos theta plus I sine theta all to the power of n, all to the power 3 in this case, sorry, is equal to r to the power 3 cos 3 theta plus I sine 3 theta. And applying your law of indices, where you have a product, this by this to the power 3, we can put the power on both terms. So that becomes, on the left hand side, r cubed by cos theta plus I sine theta all to the power 3. And that's equal to the right hand side still. And what happens then is you can divide both sides by r cubed, or the r cubes just cancel there. So what we have to do is we have the left hand side and the right hand side of the equation here. And what we take is we take just the left hand side, I call it LHS, and we work it out. So if cos theta plus I sine theta to the power 3, there's two ways you can do this. You can cube it out by multiply by itself 3 times, or you can apply binomial. I'm going to apply binomial, I think it's a bit easier. So by applying binomial, so the first value, the power starts at 3, goes down by 1. And the second value starts at power 0, so when you include that, that's I sine theta to the power 1. Remember, the two powers must add up to 3. So that's I sine theta to the power 2. And the final one is I sine theta to the power of 3. So when we work that out, again, we're just working on the left hand side. 3 choose 0 is just 1, so that just becomes cos cubed theta. So remember, put the cube after the cos. The next one becomes 3 choose 1 is 3, so that's equal to 3 cos squared theta I sine theta. So I'm going to put the I after the 3, so it's 3i cos squared theta sine theta. The next one becomes 3 choose 2 is 3 cos theta I squared sine squared theta. And remember, the I squared becomes minus 1, so when you multiply by minus 1, you just get a minus in front of the 3 there. And finally, 3 choose 3 is 1, so that becomes I cubed sine cubed theta. So that's the left hand side worked out. And again, just remember, an I squared was minus 1, that's why it becomes minus 3, and I just brought the I to the front there. So what we have then is, and you could actually, the last step there, we don't have to do it now, but probably the best way to do it. Remember, I cubed can be written as I by I squared, and I squared is minus 1, so I can rewrite that as minus I sine cubed theta. Probably a better way to write that. So I can write down the left hand side again here. So I'm going to cos cubed theta plus 3i cos squared theta sine theta minus 3 cos theta sine squared theta minus I sine cubed theta is equal to the right hand side. So it's equal to this, is equal to cos 3 theta plus I sine 3 theta. And then we just have to remember, and it's a big long thing, we have to remember that the real numbers on the left, so everything without an I, so this is no I, this is real, is equal to everything real on the right. The same with the imaginary, everything with an I value is equal to the I values on the right. So because we're proving the cos cubed theta 1 from back to the start, that's where we leave the real equal to the real. If we're proving the sign, we leave the imaginary equal to imaginary. So everything real in my example here is underlined in green. Let's rewrite it out again. So in the cos cube theta minus 3 cos theta sine squared theta is equal to cos 3 theta. What we're trying to prove again at the beginning has no signs. So this is just an important trigonometric proof we must remember. So on page 13 of the log tables, it states that cos squared a plus sine squared a is equal to 1. So rearranging that, I don't want sine squared. So sine squared a is equal to 1 minus cos squared a. So I can sub in 1 minus cos squared theta for sine squared theta. So by using that rule, instead of the sine squared theta, I'm going to put in, sorry, it's not cos squared theta, it's just cos theta. So minus 3 cos theta, instead of sine squared theta, I'm going to put in 1 minus cos squared theta. When you multiply that out, you get cos cube theta minus 3 cos theta by 1 is just minus 3 cos theta. When you multiply minus by minus becomes plus. 3 cos theta by cos squared theta is plus 3 cos cube theta is equal to cos 3 theta. These two go together because they're the exact same terms. So 1 cos cube theta plus 3 of them is 4 cos cube theta minus 3 cos theta, and that's equal to cos 3 theta, which is what we were trying to prove at the beginning. And if you were trying to prove the sine one, all you would do is exact same steps up to this step, and instead of letting the real equal to the real, we'd have left the red equal to the red.